All right, we have reached our last video of 1.3 notes, boundedness. And again, we are not going into super detail on these type of things. We are just looking at a graph and deciding whether it is bounded or not and what type of boundedness it is. So this particular graph goes on and on and on forever above, so at the top. So we say it's not bounded above, but it is bounded below. Why is it bounded below? Because there is an absolute minimum. There's a spot where it stops and it never goes lower than that. So all of that spot down there will never have part of the graph on it. So it is bounded below. Okay. So you may notice that B would be the opposite of that. It has absolute maximums where it never goes further than that. So that's called bounded above. And it keeps going on forever and ever south. So it is not bounded below. Thinking about this one going on and on and on forever. It's going on forever up, on forever down. So we simply just say not bounded because it's not bounded either way. And then our last example. We have tops, we have bottoms. It does not go on forever, it stops. So it is completely 100% bounded. So to look at the definitions here, it's bounded above if there is some number b that is greater than or equal to every number in the range. So range is your y value. That's why I kept saying up and down. Okay, this is called an upper bound. Bounded below, you have a lower bound. And it is bounded if it is both above and below. Okay. So the last examples here, if you think you have that, then you are finished. However, I will keep going for these three examples. We're going to use Desmos to graph and then decide. So the first example was x cubed minus 3. If you look, oh, I can't read, just kidding, it was x squared. I say this does not look like the graph on my key, but that would be why. All right, x squared, it is bounded below because it is bounded at 0, -3. So -3 is the lower bound. All right, instead of switching back and forth to the notes, I'm just going to keep on going here. Our next function is 3x divided by 1 plus x squared. All right, if you notice, there is an absolute top and an absolute bottom. Therefore, it is bounded. Even as you zoom out, it's forever going close to 0. So it is bounded. The third example looks like this. It is bounded below because it stops at 0. Even though it's got that asymptote there and it's going right forever, the range stops at 0. Therefore, it is bounded below 0. All right, you have now finished your notes. Finish your last activity, turn it in and do the target. And 1.3